Okay, thank you. Can everybody hear me okay? Okay, good. Right, I will start. So, hi everybody, my name is Owen Powell, and I work for a company called Arab, and I'm going to talk to you about 3D visualization and some cartography. So what I'm going to cover is a bit about me and my background and where I'm from and what I do. I'm going to concentrate mainly on Blender, which is a really good piece of software. I'm going to show you some examples of my work and then actually get into some live demos and open up Blender to show you how I make my work. So my day job is I'm a senior GIS consultant for Arab, and probably a lot of GIS people will recognise that GIS covers all kinds of different areas. So I get involved in spatial analysis and automation, visualization, making maps, cartography. But specifically today, I'm going to talk to you about the visualization work that I do. So Arab is traditionally a civil engineering company, and Arab has been responsible for the design and engineering for a lot of the world's iconic buildings and structures. So the company designs things from bridges to roads and railways, but we also have a big advisory part of our business and consultancy. So unlike a lot of people in the GIS industry, I did not study GIS, shock horror. I didn't even study geography, but I went to art school and I did a degree in fine art, and I studied painting and photography. After graduating, I did a couple of postgraduate courses in digital imaging and 3D modeling and animation. And then I graduated with a fine art degree, which is fairly useless, and I applied, as you do, you move back home, and I applied for a few random jobs in a local paper, and I happened to get one for a GIS company, and whilst it was quite a random choice, I'm really glad that I did, because I found it really fascinating. I've been working in GIS for about 15 years now. So the main thing I wanted to talk about was Blender, which is, if you're not familiar with it, it's a completely free and open source piece of software. And it's used for 3D modeling and animation and visual effects. And it's mainly capable of producing some really high quality renders and animations. So this is some examples of the type of work that people do with Blender. But what I'm interested in is using Blender to investigate how 3D technology, which I see as being really at the forefront of what you can do in terms of what's going on in the games industry and in the film industry. About using those techniques and applying them to the world of data, and specifically geographic data. So this is a few examples of some of my work, and it's a mix of my own personal work and some things that I've done at Arab. So whilst you can produce some really high quality photorealistic renders with Blender, you can actually make maps with it. Not many people do, but you can, and so these are actual 3D models, so that, for example, the text are 3D elements rotated to face the camera. So it takes a bit of a different workflow to traditional GIS, but what it does give you is sort of cinematic, high quality lighting and some really good geometry and texturing options. So other things that I'm interested in is the visualization of LiDAR. So these are rivers and river catchments where the elevation of the LiDAR data varies in just a couple of meters. And through using Blender, you can first off stretch a color gradient across that complete range and really bring out the detail of the LiDAR DTM data. But you can also produce a 3D model to really accentuate that river catchment. So I sort of started producing a lot of hillshade type renders with Blender, a lot of orthographic top-down views, as a number of other photographers do with Blender, or blendographers, as I like to call them. But I started sort of tilting the camera away from the orthographic view and to more of a sort of first-person perspective, and producing landscapes, I suppose, but still based upon geographic data. Quite often in games industry and VFX, they cheat, so they might completely make up their own landscapes or use procedural textures and that sort of thing. But in the GIS world, in the data world, we can't do that. And especially in the engineering world, you really can't do that. So I like to use sort of data-driven workflows to produce these sorts of renders. So these are a couple of renders that I've done at Arup, and these are some concepts for tunnel designs. We've got what's known as a submerged floating tunnel and a traditional tunnel, but with a road and high-speed rail. So I'm going to go into Blender now and actually show you a couple of things. I'm going to sit down, if that's okay. So the first thing I wanted to show you was a few concepts of how you can produce really nice looking hillshades and topographic maps with Blender. So this is essentially a very basic geometry. So this is Blender and this is the 3D view, and you have this node-based editor to control the shaders and the materials. And what Blender is actually doing, this is a preview of the render, and it's subdividing this basic geometry, but using a height map. So much like you would have in GIS, a DTM grayscale image, where the white bits are the highest parts, the black bits are the lowest, and when you render it, it's subdividing that plane to as many times to the same resolution as your image, and then it's displacing it, so it's physically offsetting the geometry. But it does it in quite an efficient way at render time. So if I were to take off the displacement and add in the source DTM into the color input. Okay, so this is the source of that information, fairly typical DTM. So the next, I wanted to show you two more things. So there's a couple of concepts here. So first off, I wanted to talk through the process of how I made this image. And this is using, first off, the cycles renderer in Blender. And the cycles renderer is a ray tracing engine. So it will render this view, but it will actually bounce light around the model as it would in real life. And how this is done is through a function of Blender known as compositing. So what you do, so in this view it's the same DTM that I showed you previously, and you have a camera, and that camera is positioned in a sort of perspective view, and this is the preview of that render. So when you render it, you get the image, which is here. So it's okay, it's got that DTM with an aerial photo on top. It doesn't look particularly realistic though. So what you're able to do in Blender is apply a mist pass, and this is essentially the distance from the camera through the scene. So the black parts are up close to the camera and the white parts are far away. And much like you would in Photoshop, Blender has a lot of different compositing functions, so different ways of blending layers together, such as dodge, burn, multiply, that sort of thing. So here, what I'm doing is basically blending those two layers together, and doing a couple of other things like adding a vignette. So here, this node produces an ellipse shape, which is then subsequently blurred, and then I apply a colour to it, and then finally merge and blend those two together. So this is starting to look a bit better, and the final output you can sort of tweak the lighting and the colours to give you what you're looking for. So you could make it slightly less green or slightly more blue, for example. So the compositor, the idea behind this is if you were rendering out an animation, you wouldn't have to take each single frame of each individual render and adjust the colours and the lighting separately in Photoshop. You can do it all within this node setup. So the adjustments are made to each image directly after it's rendered. So that's the cycles engine, and finally I just wanted to finish on looking at the EV renderer, which is Blender's recent real-time rendering engine. So this allows you, rather than having to wait for the light to bounce around with the ray tracing engine, this is a real-time, and the key node amongst you might notice that it's slightly pixelated at first and then gets clearer. So this is using a sort of rasterizing technique for rendering. What I have here is a view with this atmosphere applied to a cube. So this, rather than using a mist pass to create that sort of atmospheric view, this uses something called volumetrics, where the actual material and the shader is applied to the interior of this cube rather than the surface. And what I'm able to do is to blend together a couple of different textures applied to the cube. So in the first instance, I had this procedural noise where I can adjust the scale of the noise, for example, to produce a different kind of cloud feel. And then this second part here is a bit more of a general atmospheric haze, where we're separating out the elevations of the Z values from the objects, and then by adjusting some sliders here, I can adjust how much the gradient fills up that cube, and do other things like adjusting the colour and make it look really horrible like that. So finally, you can mix those two textures together, so the general sort of haze and the cloud texture to make it suit. And this is a volumetric shader, so it actually reacts to light. So as I move this sun lamp up and out of the box, you only get the ambient sort of lighting and feel. And move it back in, you can sort of move it around, and it will sort of dynamically light your scene. So in short, that's about it really. So a couple of concepts of ray tracing and real-time rendering. So that's great. Yeah, thank you very much.
Fantastic, thank you, Owen. Has anyone got anything to ask? Any questions?
I'm curious. Other than cost, what would you say the advantage is of Blender over other software packages such as 3ds Max?
Yeah, it's a good question. I think one of the main ones is of accessibility. So it is completely free and open source, which means that I've been using Blender for as long as I've been using GIS. So you can learn it in your own time, and there's a large community of users and developers that that support it, and there are a lot of tutorials and that sort of thing. But personally, I quite like it. It's just it's a different sort of thing, and certainly it's not the main tool that's used within our. People use a lot of 3ds Max and those sort of traditional packages.
I work for another consultancy, so I'm not allowed to ask you the question I asked in the first speaker because I work with some of our colleagues. But I am going to ask, what is the reaction you've had from your clients in presenting the work you've done with Blender? Has it been universally, the work is fantastic, has it been universally lauded, or have you had pushback, for example, from clients?
Yeah, so to repeat the question, what's the reaction been from our clients to the use of Blender? I don't think they know, really. I think...
No, I suppose I'm not concerned about Blender itself, it's about the results that you're...
Right, so we do a lot of work with things like Unity and games engines, and the reaction to that sort of immersive environment has been fantastic with clients. And it provides, by using tools like VR, so where you're taking models built in technology such as Blender or 3ds Max, you can provide a really immersive environment which clients react to really well. And it can also be used as a demonstration tool in itself. So rather than producing lots of drawings, you have your design as a model which people can interact with and even be part of.
We've got a question at the front.
I just wonder what is the reaction of the engineers when they learn such cool visualization?
So the question was, what is the reaction of engineers to this sort of thing? I suppose they are sceptical at first. Engineers like their drawings, and they like things to be very, very precise. But the thing is, when they can see, it's like I primarily work in GIS, so when we can take real-world environments and real-world data and put that into a model with designs and engineering data, they can see it all come together and put it into perspective. So, yeah, I think there will always be a place for drawings, but yeah, we're doing things differently.
Anyone else?
Yeah, so what was the source data? So I have, in my own personal work, used a lot of open data. So in those examples that I showed you, that's Environment Agency LiDAR, so like a 1 meter DTM, which is really good stuff. And part of the reason for using Blender for that is that it has something called adaptive subdivision and micro displacement. So you can build a model and a mesh that's as detailed as your LiDAR or your source data. So you can throw at it as much information as you can.
Thank you very much.
Thank you.